What is going on, guys? My name is Hussein, and this video I want to go through the TLS 1.3 handshake. So guys, I made a video about TLS and why it's very important, comparing TLS 1.2 and TLS 1.3 and the pros and cons and why everybody moved to 1.3 and why you should check out that video here. And I also talk about encryption and all that stuff. As you know on this channel, guys, I always take a real use case from us software engineers, backend engineers, and I dive into the actual TLS handshake. So what I'm gonna do here is I'm gonna take this will be a REST API server, an Express Node.js server, right? And this is a client that is about to send a GET request. What really happens? What is this TLS thing? That's what I'm going to explain. And you guys, front engineer and back engineer, should know what happened in TLS 1.3 or TLS in general, because that extra handshake can slow things down if you don't know what you're doing, right? So you need to appreciate these small things that you're doing that the computer is doing without you actually knowing what is happening behind the scene. So guys, the agenda of this video will be the following. We're going to talk about TLS 1.3 overview, how it actually works with a GET request, and then we're going to talk about the key exchange algorithm of TLS 1.3, Diffie, hellman, how it actually works, the math of it, right? And as I speak, you should start seeing some time code so you can jump into the interesting part of the video that you're actually interested in. We're going to talk about the TLS extensions, guys, so like SNI, ESNI, encrypted SNI, ALPN, application layer protocol negotiation, and so much other stuff. And finally, I'm going to talk about how TLS 1.3 still can be man in the middle, exactly how, right? So if you're interested, stay tuned. Let's just jump into it. All right. So before we do anything, the client is about to establish a connection to the server, and the server is listening on port 443, assuming this is HTTPS. Again, guys, TLS is not just for web traffic. Yeah, I am explaining it from a web perspective, but TLS can be applied to databases, right? All databases now support TLS. Tor support TLS. Any communication between two parties, if you want to encrypt it, TLS is your... So this is listening on port 443. And here's the thing, the client needs to be aware that it's about to establish a TCP connection and it's about to establish TLS, which is this encryption communication. But what happens here? I want to send a GET request. That's all what I want. I want to get the index.html. The first thing that happens, those two guys will establish a TCP connection. Assuming this is HTTP 2, right? HTTP 3 and quick is a little bit different, but assuming this is HTTP 2, what will happen here is the client will attempt the three-way handshake to establish a TCP connection. And once this TCP connection is established, now you can send information on top of each other. So that's the first thing that the browser, if you're in the browser does for you, okay? Now you send the GET request, but before the GET request, the second thing that happens here is the TLS handshake. And I'm going to represent it here as just one arrow. It's actually two arrows, like it's a one round trip. The client sends information, something, client hello, and the server responds with something. And the goal of this green line for both the server and the client to agree on one key. And I'm about to draw a badass key right here. Look at that. And that key, think of it as like a symmetric key. So that means the same key encrypts and the same key decrypts. And the goal of this, and because the symmetric key is so fast and so optimized, AES for example, right? This is the preferred method of encryption. So now the client, once they agree on this key, and we're going to talk about how they agree on this key, now they can safely start encrypting information and sending information. So now the next request will be the actual GET request to get the index.html or the JSON or whatever, right? But that GET request, all its header, everything will be encrypted with the client symmetric key, which the server happened to have, by the way, because they exchanged it somehow magically. So yeah, so this thing is encrypted. That's supposed to be a lock, yeah. Zam. All right, so this is a lock, and then the server will receive that GET request. It's just a mumbo jumbo encrypted stuff, so it will use that key to decrypt that. And once it knows, it will now obviously process that request, read from the disk, reads it to the database, whatever it does, and then responds back with, I don't know, the JSON response and all that jazz. All right, so that's what happened here, guys, right? So there is some, and this is what I'm gonna explain in this video. We're gonna unpack what happens right here, the math and all that jazz. How about we actually jump into the video? All right, guys. So the goal of the TLS handshake, the main goal, we're using the TLS handshake for so much stuff, but the main goal is for those two to agree on the same key, right? And what is a key? A key in computer is just a number. So the idea is here, if we have a number here somewhere, I need this server to have the same number. I cannot generate this number on the client and send it over because someone can sniff it and just obviously know it, right? So we don't want to do that. So what we need to do is do this. Here's where two smart people, they came together, they called Diffie and Hellman. Diffie Hellman came up with a key exchange algorithm so that anyone that sniffs here in the middle, right? If it's like it acted like anyone that sniffs in the middle, so acts like the network hub or something and try to see the traffic, they will not be able to assemble that key. It will be very hard for them. So what does that do? The client will come up with a private number. Let's say X, right? The client will come up with a private numbers that is nobody knows about it, X, right? And it also can come up with a public number. Let's call it G, right? This public number is gonna send it in the client hello, right? And that's it. What it's gonna do? The client will send this information now, and I'm gonna simplify this a little bit, right? And this is called the client hello. The client hello. The client will take G and raise it to the power X. So if someone sniffs G to the power X, they cannot find X because, right, it's just very hard to determine. You need to take the, I don't know, the logarithm of G, the logarithm to the base G in order to get the X, right? It's very, very hard to break, right? So that's okay. This is public. It also sends the G, which is okay, right? And here's what is so lovely about this, right? So they take G to the power X, and this also sends G, and it sends so much information that we're going to talk about later. It says, so talk about the TLS extensions like ALPN. By the way, I support HTTP2, OCSP stapling. I support all that stuff, right? So that we overload this TLS handshake with so much information, like ESNI, right? Server name indication, encrypted ESNI, all that stuff. We send it along, right? But I'm not gonna talk about it in this round. I'm gonna talk about it later. We send it over. The server receives it. Now the server has what? Has G to the power X, and it also has G. Now the server responsibilities take up another private variable, right, called Y, and it will come up with G, take the G and raise it to the power Y. Ooh, fancy. And the server will reply with the following information. It will reply with G to the power Y, which is okay, because even if you raise G to the power Y, you cannot find Y, right? Even if someone sniffs here, right? And it's gonna respond with whatever the symmetric key encryption that they agreed upon, because the client will say, hey, I support EAS, I support so many symmetric algorithms, right? But the server will say, okay, we agreed on AES, for example, right? And here's G to the power Y, okay? And here's what the server does. The server will raise G to the power X, which it got from the client, to the power Y. And if you know a little bit of a math, what does this equal? This is equal to G XY, right? Because you kind of multiply these together, right? And if someone now, who's the sniffing here, right? Alice, Bob, and Dave. Not Dave, Charlie. Let's call him Karen. So Karen here, right? That's supposed to be Karen. That looks like a monster. So Karen here sniffs, and she got G to the power X, and she got G to the power Y, right? Can she derive G to power XY? No. The only thing she can do is if she multiply these together, she will get what? G to power X plus Y, which is a completely different number, right? So now she cannot get this thing, right? So so now this is the trick here. That's the secret number that this guy. Now, what the client will receive that thing. So now the client will receive G to the power Y, right? And it will raise it to the power X, because guess what? It has the X, and this will equal to G to power XY, right? Or YX, the same thing, right? So now we got it, guys. Both those guys have the same number, okay? And obviously there's something I missed here, and I don't want it to just complicate things. So that's the idea. There's another modulo number here. There's another number called n that is sent, and those guys will take the modulo of n, and so they get a reasonable number between 0 and n, okay? And that's the idea, but that's the goal. We got the same key, and we can use this input as a feeding algorithm to our symmetric key encryption. All right, guys, so that's the TLS 1.3 handshake. How about we go deep into not the actual math now. Let's go about the TLS extensions, right? Let's erase this stuff and go to the TLS extension. So this video, guys, was inspired by the comment of Inquisitor, someone named Inquisitor, and I really loved the comment that he put. And I wish he has a channel. He has no subscriber, but he is very, very knowledgeable. He comments on every video and adds a lot of insight. So I'm gonna give kudos to him. And he explained this handshake in a very elegant way, and that's why inspired me to make this video for you guys. Right? It was really simple. So that's why I decided to make this video. So now let's talk about the TLS extensions, guys. So what happened here is let's again unpack the client hello. The client hello. Right? We talk about, we send this GX, and we send G to the power X, and we send the N, the number, the modulo, and we also send the TLS extension. And this is what I am interested in here, guys. So the TLS extensions, right? It's very critical. We have so many extensions, guys. You don't even know, right? So one of the extensions called ESNI, and I made a video about ESNI, server name indication, because this server can actually supports shared hosting. So it's like it supports a domain called a.com or b.com or c.com, right? It can support all of these domains in one IP address, essentially, right? So the client, when it sends the server name indication, right? How does it, so the client, when it starts to establish the TLS communication, the server responds with what? With the certificate, right? We didn't talk about certificate much in this channel, huh? I need to make a video about it. But the certificate essentially is a proof that this server is actually host a.com. This server is actually b.com, or this server is actually c.com, right? Or if you go to Google, how do you know this is actually Google and not some other shady person, right? This is how we do it. You know it. Essentially, you know it because of this information, right? Because the server sends you this certificate that is being signed by a third party like Digitine or Let's Encrypt, right? So now the ESNI case here is the server name indication. The client during the TLS handshake sends which domain it exactly tries to communicate to. It says, hey, I'm about to establish a TLS communication with you, but I'm interested in this particular domain, right? And it knows because you probably typed it in, right? https://a.com, right? It will send it this, and that's a plain text. And this is a problem that people are solving it right now, because we can see where you're going, right? And that's bad. So there is another extension called ESNI, encrypted ESNI, which I'm not gonna go in this video, but check out the video I made about encrypted ESNI if you're interested. So that will send that, and once it receives it, that server will serve the certificate of a.com, right? And if it says b.com, it will serve the certificate of b.com and c.com. And that's how you can host multiple sites securely on the same IP address, because static IP addresses are very expensive, guys, right? So now we'll send that information and then send it back. So ESNI is one extension, the TLS extensions that's happening in the TLS handshake, right, guys? And also, as part of the TLS handshake, the client says, hey, I support this encryption algorithm, AES 256, right? And I support Blowfish. I'm just making encryption algorithm from 1998 when I went to school, right? Because I don't remember what is the most powerful encryption algorithm. Again, I'm not a security engineer. I'm a backend engineer, guys. And I like to dive into these stuff, right? And yeah, so Blowfish, I support this. And the server will say, okay, this is like a shady encryption algorithm. This is like a shady encryption algorithm. Let's use this one, right? And this is where downgraded attacks happen most of the time, right? TLS 1.3 is definitely can be man in the middle real hard if you want to, right? But if they are sniffing, just sniffing, they cannot know anything, obviously, right? But if they decided to actually reply, right, with their information, if they decided to intercept the traffic, then that man or woman, I don't know why they call it man in the middle. That's just misogynist, right? That man in the middle can reply with their own certificate, and what it will happen is, and this is a problem that people still solve, right? So I guess we're talking about man in the middle, huh? All right. So what will happen here is, let's talk about man in the middle real quick, guys. I know probably the video is done, but I like to talk about these concepts, guys. So let's talk about man in the middle. So what will happen here is, here's how TLS can be man in the middle, right? You gotta make a client hello, and you gotta say, hey, G to the power X, right? And you're gonna say G, right? That main, let's find a main or a woman. All right, Karen is the man in the middle in this case, right? Let's just not be misogynist, right? Because women can perform this attack, right? It's just, yeah, of course. It's like, I don't know, like who came up with this name, really, to be honest. Like, man in the middle, why does it have to be a man? Jesus. All right, so Karen here will intercept that attack and will say, well, wait a second. I'm going to reply back. I'm going to assume the role of the server, and that she absolutely can do this. She can pretend to be the network hub and respond with its certificate, its information. Obviously, the client need to verify the certificate that it's really a.com or b.com or whatever.com you're going, right? But she will reply with, hey, x to the power y or x to the power z, right? The client doesn't know. I was like, yeah. And the client will do x to the power xz, right? That's the key. And then she will send her key, g to the power z, to the server. And the server will say, share, because the server is from Boston for some reason, right? Share. So the server will reply with what? G to the power y. And now Karen have GZY. And this guy will have GZY as well, right? That's just nasty. Now, what? Now, she has GZY and she also have GZX, right? So what she's going to do is, any communication between the client and the server, she's going to use what? She's going to use this, right? Any communication between the client and Karen, she's going to use this. And any communication between Karen and the server, she's going to use this. And she's going to encrypt the traffic and decrypt it and send it over. So she's effectively man in the middling, real hard. All right, guys. So that was TLS 1.3 Handshake and so much other stuff, I guess. All right. Hope you enjoyed this video. I'm going to see you in the next one. Hopefully you enjoy this content, guys. And if you do, give it a like, subscribe, and share it with your friends. I talk about backend engineering in specific. I also talk about these concepts sometimes from time to time. And leave your questions, because any question you ask below, all right? First of all, you make me really think hard about everything, because if your questions are really challenging, to be honest, and then if I answer, I can sometimes make a video about it. The other thing is, like, communities come together and start answering your questions, and we get a lot of love in the comment section compared to other YouTube comment section, right? I don't get a lot of hate. Maybe in a few more years we're gonna see the hate, but now so far it's just love, and I love it, guys. Love you so much, guys. See you on the next one. What should I talk about next? You guys stay awesome.